Hello friends, Jai Shri Swaminarayan. Now let's move forward. Question number 2. First of all, read this question. Prove that 3 plus 2 under root 5 is irrational. Okay, 3 plus 2 under root 5 is irrational. Same method we use here, it is contradiction method. Okay, in contradiction method what we need to do? We need to assume the opposite things, right? Here we need to prove this number is irrational, so we need to assume this number is rational. Okay, this is contradiction method. So here assume 3 plus 2 under root 5 is rational. Okay, we need to prove it irrational, but we use here contradiction method. That's why we assume that 3 plus 2 under root 5 is rational, and we need to try that our assumption is wrong. Okay, so first of all assume 3 plus 2 under root 5 is rational. Now if this number is rational number, so we can represent it in the form of p by q, right? Here in place of p by q I am using a by b. Okay, so this number is rational, so we can represent this number in the form of p by q. Here I am using a by b, where this a and b are co-prime numbers, right? Co-prime numbers, that means nothing is common in between this two number, right? There is no common factor in a and b. It means that where SCF of a and b is equals to 1, right? SCF of a and b is equals to 1, that means there is no common factor. Okay, now from here we need to try that we just want under root 5 in left hand side. All the other things we need to transfer to the right hand side. Okay, in left hand side we only want under root 5. Other things 3 and 2, that we need to transfer to the right hand side. Okay, so here under root 5 we need to put in left hand side, so 2 under root 5 as it is. First of all transfer this 3 to the right hand side. Okay, first of all transfer this 3 to the right hand side. So here 2 under root 5 as it is, a by b as it is. If we transfer this plus 3 to the right hand side, it becomes minus 3. Okay, first of all here if we transfer this plus 3 to the right hand side, it becomes minus 3, right? So here a by b minus 3. After that we need to take LCM in right hand side, right? Here we have 2 under root 5. First of all take here LCM, so a by b minus 3. Now a as it is, 3b cross multiplication, so minus 3b divided by b. Otherwise here we have denominator b, so we can multiply here b and divide by b. Okay, multiply by b and divide by b. So denominator b same, so here in denominator b, a minus 3 multiply b, 3b. Okay, so a minus 3b divided by b. Okay, here we need to take LCM. Now after that here we want only under root 5, so we need to transfer this 2 to the right hand side, right? So we need to transfer this 2 to the right hand side. So here under root 5 is equals to a minus 3b upon b, and if we transfer this multiply 2 to the right hand side, it goes to the denominator. Okay, so under root 5 is equals to a minus 3b by 2b. We need to transfer this 2 to the right hand side. Okay, now in left hand side we have only under root 5. Why we put under root 5 in left hand side? Now I will explain you. Okay, here in left hand side we have only under root 5, so here give the equation number 1. Okay, now if we look at this equation, here a and b are integers. Okay, co-prime numbers, and it is one rational number, but itself in rational number numerator and denominator are integer numbers. So a and b both are integer numbers. Okay, so here a integer number, 3 integer number, b integer number, 2 integer number, and b integer number, it means that here our right hand side is rational number. This all numbers are the integer numbers, right? And here we have numerator and denominator, that means this is rational number. Okay, so now we can write like this here, that means in this equation a and b are integers. Okay, it means this right hand side of equation 1 is rational, right? These are the integer numbers, so it forms one rational number, so our right hand side is rational. But we know that this under root 5 is irrational number. We already proved this in our previous video, right? Under root 2, under root 3, under root 5, under root 7 are irrational number. Okay, in under root prime number is there, then it is irrational number. So we already know that under root 5 is irrational number. So here our left hand side is irrational number. Left hand side under root 5 is irrational number, but our right hand side is rational number. So this is not possible, right? Left hand side irrational number, right hand side rational number, so this is not possible. Okay, so here we can write like this. It means right hand side of equation 1 is rational, but under root 5 is irrational. It is not possible. It is not possible, it means our assumption is wrong, right? Therefore our assumption is wrong. Now if our assumption is wrong, it means that 3 plus 2 under root 5 is not a rational number, right? Our assumption, what is our assumption? 3 plus 2 under root 5 is rational. If it is wrong, it means that this is not rational number. And we know that a number, if it is not rational number, then it is called an irrational number. So alternately 3 plus 2 under root 5 is irrational. So we can write like this. Hence 3 plus 2 under root 5 is irrational. Okay. So in this way we can prove this by using the contradiction method. Okay. Now I repeat this question quickly. First of all, assume this is a rational number. If this is rational number, so we can represent it in the form of a by b, where SCF of a and b are is equals to 1. Okay, now in left hand side we only want under root 5, so transfer this 3 to the right hand side. Okay, so here 2 under root 5 a by b, if we transfer this 3 to the right hand side, it becomes minus 3. After that we need to take LCM here, so it's a minus 3b by b, and we need to transfer this 2 to the right hand side, so under root 5 is equals to a minus 3b divided by 2b. Here we need to give equation number 1, and here a and b are integers. Here our right hand side is rational number, but our left hand side is irrational number, so this is not possible. It means our assumption is wrong. Hence 3 plus 2 under root 5 is irrational. Okay. One more thing, if this question asks in 1 or 2 marks, then we need to write up to these steps. Okay, if this question is asked in 1 or 2 marks, then we need to write this answer. But if this question asks in 3 or 4 marks, so first of all you need to prove that under root 5 is irrational number, that we already proved in our previous video, right? So first of all you need to prove under root 5 is irrational. After that you need to write these steps. Okay, if this question asks in 3 or 4 marks, so first of all you need to prove under root 5 is irrational. After that you need to prove this. Okay, because here we directly written here that under root 5 is irrational, we do not prove it. Okay, we directly take under root 5 is irrational, but if this question asks in 4 marks, so we need to prove this under root 5 is irrational. After that we can write these steps. Okay, then question number 3, internal question number 1. Read this question. Prove that 1 upon under root 2 is irrational. So here we use the same method as we use in question number 2. Okay, again we use the contradiction method. So here we need to prove 1 upon under root 2 is irrational. So we assume the opposite things. Assume 1 upon under root 2 is rational. Okay, assume 1 upon under root 2 is rational. Now again, if this is a rational number, then we can represent it in the form of a by b, right? If 1 upon under root 2 is a rational number, then we can represent it in the form of a by b, right? Where SCF of a and b is equals to 1. Okay, now sum as we use in question number 2. Here we have under root 2. So in left hand side we only want under root 2. Okay, in left hand side, otherwise in whatever side, either left hand side, otherwise right hand side, but in one side we want only under root 2. Okay, it can be in right hand side even, but either left hand side, otherwise right hand side, we want only under root 2. Okay, so here what I do, that is just I take the inverse in both the side. Okay, I just take inverse in both the side. So here inverse of 1 upon under root 2. So this under root 2 goes to the numerator and 1 goes to the denominator. It means under root 2 divided by 1. But if we do not write divide by 1, then our answer is right. Otherwise, under root 2 divided by 1, it is under root 2 only. Right? So here I am taking inverse in both the sides. Why I am taking inverse? Because I want this under root 2 in numerator. Right now it is in denominator. That's why we can take inverse. Okay? So same thing we need to do in right hand side even. So here even we need to take the inverse. So this b goes to the numerator and a goes to the denominator. Okay? So under root 2 is equals to b by a. Otherwise, you can transfer this under root 2 to the right hand side and a by b to the left hand side. Okay, you can also do these things. That means transfer this under root 2 to the right hand side and transfer this a by b to the left hand side. If you transfer this under root 2 to the left hand side, it goes to the numerator. Okay, so here under root 2, that means same thing as we write in left hand side. So here our under root 2. Now if we transfer this a by b to the left hand side, so this denominator goes to numerator, numerator goes to the denominator. Alternately you get under root 2 is equals to b by a. Okay, same thing, whatever way you want, you can use it. So here our under root 2 is equals to b by a. Now same thing we need to write here. Okay, give the equation number 1. After that, here a and b both are integers, right? And b by a, it forms one rational number. So our right hand side is rational, but we know that under root 2 is irrational number, right? It means our left hand side is irrational, right hand side is rational. This is not possible. Okay, so here a and b are integers. It means right hand side of equation 1 is rational, but under root 2 is irrational. It is not possible. Therefore, our assumption is wrong. Our assumption is wrong. It means that 1 upon under root 2, it is not a rational number, but it is irrational number. Okay, so same method we can use here. Again, quickly repeat these things. 1 upon under root 2 is rational. If it is rational, so we can represent in a by b. Okay, now take the inverse. Otherwise, transfer left hand side to right hand side and right hand side to left hand side. You will get under root 2 is equals to b by a. Give the equation number 1. Here, our right hand side is rational, but left hand side is irrational. This is not possible. Therefore, our assumption is wrong. Hence, 1 upon under root 2 is irrational. Okay? And one more thing, if this question asked in 4 marks, otherwise 3 marks, so you also need to prove, first of all, under root 2 is irrational. Okay? Then, in similar way, we can prove this question number 2. Okay? Here, prove that 7 under root 5 is irrational. Okay, prove that 7 under root 5 is irrational. Okay, again we are using contradiction method, so we need to assume opposite things, right? So here we need to prove irrational, so assume 7 under root 5 is a rational number. Okay, and if this is a rational number, so that we can represent this number in the form of a by b, right? So 7 under root 5 is equal to a by b, where HCF of a and b is equal to 1. Okay, first of all we assume 7 under root 5 is rational number. If this is a rational number, then we can represent this number in the form of a by b, right? Where HCF of a and b is equal to 1. Okay, now we want under root 5 in left hand side. Okay, in one side we only want under root 5, so that we need to transfer this 7 to the right hand side. Okay, here we want only under root 5, so that we can transfer this 7 to the right hand side. So under root 5 is equal to a upon 7b. Here 7, it is in multiplication. If we transfer this 7 to the right hand side, it goes to the denominator. Okay, so under root 5 is equal to a upon 7b. Here we have only under root 5, so give here equation number 1. Okay, now we need to write the same steps that we have already written in equation number 1. Okay, so here a and b both are integers. Okay, a and b are integers. It means that our right hand side is rational. Okay, here a is integer number, b is integer number, 7 is integer number. So in numerator we have integer numbers, in denominator even we have integer numbers. So this forms rational number. Okay, so our right hand side is rational. So here our a and b are integers. Okay, and it means that our right hand side is rational, but in left hand side we have under root 5, and we already know that under root 5 is irrational number, right? So here our right hand side is rational, but left hand side is irrational. So this is not possible. That means our assumption is wrong, right? Our assumption is wrong. It means that 7 under root 5 is not rational number. If it is not rational number, then it is irrational number. So we can write like this. Hence 7 under root 5 is irrational. Okay, so in similar way we can prove this sum. And here even if this question is asking 4 or 3 marks, then first of all we need to prove that under root 5 is irrational. After that we can write this steps. Okay, again 7 under root 5 is rational. If it is rational, then we can represent in the form of a by b. If we can represent in a by b form, okay, so here our HCF of a and b is equal to 1. Now we want under root 5 only, so transfer this 7 to the right hand side. So under root 5 is equal to a upon 7b. Here equation number 1. Here our right hand side is rational, but left hand side under root 5, that we already know that under root 5 is irrational number. So right hand side rational number, left hand side irrational number. This is not possible. That means our assumption is wrong, and if our assumption is wrong, it means that 7 under root 5 is irrational number. Okay, then in similar way we can prove question number 3. Okay, in this question prove that 6 plus under root 2 is irrational. Okay, we need to prove 6 plus under root 2 is irrational. Same method we are using here, contradiction method. Okay, so here we need to prove it irrational number, so we need to assume opposite things. So assume 6 plus under root 2 is rational. Okay, we need to prove it irrational, so assume the opposite things. That means 6 plus under root 2 is rational number. Okay, again if this is a rational number, then we can represent this number in the form of a by b, right? If our 6 plus under root 2 is rational number, then we can write in the form of a by b. Okay, so 6 plus under root 2 is equals to a by b, where SCF of a and b, where SCF of a and b is equals to 1. Okay, that means a and b both are co-prime numbers. That means there is no common factor in between a and b. Okay, now what we want, here we have under root 2, right, and we know that under root 2 is irrational number, so we want under root 2 in one side. Okay, so here under root 2 is in left hand side, so in left hand side we only want under root 2, so all the other numbers we need to transfer to the right hand side. Okay, so here under root 2, now transfer this 6 to the right hand side, so here we have a by b, and if we transfer this plus 6 to the right hand side, it becomes minus 6. Okay, so a by b minus 6. So under root 2 is equals to, now we need to take LCM here. Okay, so here we need to take LCM, so a minus 6 into b, 6b divided by b. Otherwise, we can multiply b and divide by b here. So denominator becomes 7. This is LCM, right? So here denominator b and in numerator a minus 6 multiply b, 6b. So a minus 6b divided by b. So under root 2 is equals to a minus 6b divided by b. Here in left hand side we have only under root 2. So here we need to give equation number 1. After that we need to follow the same steps that we follow in equation number 1 and 2. Okay. So here a and b are integers, right? Here a and b are integers. So here a integer, b integer, b integer, 6 integer. That means our numerator and denominator both are integer numbers. Okay, and if our numerator and denominator both are integer numbers, it forms rational number, right? So this is rational number. So here our right hand side is rational number, but in left hand side we have under root 2, and we already know that under root 2 is irrational number. So left hand side is irrational, right hand side is rational number. Okay, so we need to write this. A and b are integers. It means right hand side of equation 1 is rational, but under root 2 is irrational. It is not possible. Okay, it is not possible. Therefore, our assumption is wrong. And if our assumption is wrong, it means 6 plus under root 2 is not rational number. If it is not rational number, then it is irrational number. Okay, so hence 6 plus under root 2 is irrational number. So in similar way we can prove this sum. Okay, now if this question asks in 4 marks, then what we need to do? First of all, we need to prove that under root 2 is irrational. After that we need to write this steps. Okay, again quickly repeat these things. 6 plus under root 2 is rational. If it is rational, then we can represent in the form of a by b, where SCF of a and b is equals to 1. Here only we want under root 2, so transfer this 6 to the right hand side. So a by b, if we transfer this plus 6 to the right hand side, it becomes minus 6. And here we need to take LCM. So a by b minus 6. Okay, so a minus 6b divided by b, and give the equation number 1. Here our right hand side is rational, but left hand side is irrational. Okay, so it is not possible. Therefore, our assumption is wrong. It means 6 plus under root 2 is irrational number. Okay, students. So here our exercise 1.3 is complete. If you have any doubt in this question, please write down in comment section. I will give you the answer. Thank you.